Hi, this is Denise, Elektor Community Manager.
Hello, I'm Arthur from Elektor.
Hello, I'm Rajat from Elektor.
Hi, welcome. This is Clemens at Embedded World 2020.
We are at Embedded World 2020 in Nuremberg. Let's take a look inside.
So this is Clemens at Embedded World 2020. Here we are standing in front of the Schurter booth. Next to me is standing Mr. Roland Maurer. He's a product manager. And well, Mr. Maurer, can you tell us something about what you have on the booth?
Welcome to our booth. So I want to show you the newest innovation about input systems. This is a resistive multi-touch screen, because a lot of applications you can't use PCAP because physically the PCAP is not usable. Like you have a high EMC field or a lot of water. So for medical application it's a must. For some kind of medical application it's a must to make it resistive, but for new applications you need to have a multi-touch screen. Therefore we developed a resistive multi-touch screen. It's also usable for military applications. You can shield it with a metal mesh. So it's really perfect.
Okay. Looks nice.
Don't want to miss multi-touch. Okay, you can also make a GFG out of it. That means a glass cover over it with UV cut material, so you can use it for outdoor applications. This is a indoor communication system. It's a pretty easy electronic design. That means the sensor of the switches is on a PCB board. We make a blade between which makes the light. So you can use very easy PCAP switches behind a glass overlay, plastic. You can integrate it in the wall. So it's a special design for one customer.
Looks nice, I must say.
It looks nice. It's really perfect and easy to activate. Okay.
Nice.
This is an example for avionics and space. It's an in-flight entertainment system. It's also PCAP behind a chemical strength glass that it will not break. The specialty of this application is we make a sensor which is larger than the display, and you can use around the active area of the display and use the sensor film to make additional PCAP switches in it.
Yeah, so it's important to know that you do not design the whole system, but you make the sensors that allow it to be controlled by the user.
They can be used, of course, yeah. And you can program by yourself or by the customer. You can define how big is my zone you want to use. You can, for example, you can make a switch which complete area. So for on-off, it's pretty easy. Okay. So one controller, two different outputs. One is the multi-touch and one is like a keyboard, a real keyboard signal to the system.
Okay. Nice. Normally in-flight systems, they often have problems. I hope this one is better.
This one is pretty perfect good, yeah. Of course. In the beginning it was resistive, now also changed to PCAP.
Okay.
Yeah.
Good.
So for example, this is a typical PCAP panel for backside integration in a housing, in a metal housing. And you see here the difference between optical bonding and not optical bonding. So the readability is perfect good. If it is bonded, you have a better usability also according to high humidity and so on. And the ruggedness is really much better.
Very strong.
Strong, yeah.
Okay.
This is a standard module. It's an IPC, ready integrated, made in Taiwan. So just if you have not special requirements, you can use such an easy IPC system with defined interfaces here. Also here with switches in it. This is as I know, worldwide first PCAP for locomotive control. Because locomotive has a very high requirement for EMC, because the energy in a locomotive, the disturbance is really high. So you have to test maybe around 100 volt per meter.
Okay.
And it's the CL2 norm standard we have to fulfill. And with this PCAP panel we fulfill this norm. It's also a chemical strength glass, 3 mm thick, so a high IK08 level, and anti-glare surface. Optical bonded display, so perfect. And finally, really, you see a rugged housing, closed, fanless.
And then you play Tetris on it, I see.
It's just for the customers. A very good example we make for a special customer in Germany for the e-car production. It's a 24-inch PCAP sensor, film-based in this case, behind printed glass. By the way, the glass printing is in our factory in Endingen in Germany. Okay. We have a fully automated production line where the touch don't need to be touched, the glass, during the production. The specialty here is we have a logo design which is illuminatable. That means you can see the status of the machine, and each worker sees from far distance the status of the application. And so we delivered around 1,000 panels, which are standing now on each working place in the car production.
Okay. It looks nice.
It's pretty nice, yeah. Also special in this case that you can control each touch panel from one office.
This is the biggest size you can do, or you can do even bigger?
No, the biggest is at the end. Okay. This is a 32-inch PCAP based on glass. Glass has the big advantage, it's a very high light transmission and a less haze rate. That means the picture in the screen is really reality what you see. It's not influenced by the sensor, not influenced by the material between. So therefore perfect for medical applications as well. You can see the real picture in the display. And this is just for play.
Roulette.
You see we can also integrate the status LED in rows. So you won.
I won. Well, actually you won.
Okay. We can also make optical bonding in this size. So 32 is in our view currently the maximum size for industrial and medical applications.
Very impressive. So here we are at the medical division.
The 21.5 display, optical bonded with the cover lens, printed with white color because for medical application. And this is, we say, open frame design that you can integrate it by yourself or in the ready unit or in a big housing you can integrate it by yourself. There's a rubber sealing around, so you define the cutout of the application and you integrate the ready touch panel with display, by the way, into the system.
Okay, here we are standing with Mr. Ubaldo Tarantino.
Nice to meet you.
Nice to meet you. You are going to tell us something about the embedded systems from Schurter.
Yes, correct. We can show you something. We are based in Italy. Okay. We are the system division for Schurter. What we are currently promoting and manufacturing are this kind of solutions where we can have embedded board like this one. We design the system on module with the operating system on it, Linux and Android based typically. And we can design the carrier board, the board designed for the customer with all the interfaces the customer needs like USB, HDMI interface, CAN bus and so on. We can take the design of the customer or we can help the customer design by co-designing the board itself and provide a complete solution even with certification and tests. Medical application, industrial application, automotive application, we can do without any problem. What we are doing is even integration with products of other products of Schurter's like capacitive touch panel, the possibility to have HMI solutions with a complete system, again like this one, integrated into a mechanics solution with display, full HD display, capacitive touch panel, and a complete range of product. The solutions can be customized, of course, with different kind of displays, resistive technology, capacitive technology, full HD displays, and even about the requirement about the system memory or anything the customer needs about interfaces, we can do according to customer requirements.
So now Schurter not only makes parts but complete systems actually.
Yeah. This is the real goal for the company from the Swiss border to be a competence and added value company. So to provide not only components, because in Italy we had the philosophy to provide components originally from our background history, but in the past 2 years we are going more and more to be a solution provider, to start to provide a complete system, give added value, become more partner with the customers, not only as suppliers.
Okay, very good. Well, Ubaldo, thank you very much.
Thanks for
and I wish you a nice show. And see you next year, maybe.
For sure. Thanks a lot, and thanks to your readers too. Okay. Thank you. Bye.
I have a wonderful electronic invention I want you to see.
It looks something like this.